Hello and welcome to this new video in the Learn C# series, and today we're going to be covering arrays in C#. Before we go any further, if this is your first video, I have an upcoming internship that requires I know C#, and so I find the best way of learning is actually through teaching. So I'm creating the series where we get to learn together. In this series, we're using Learn C# 12 and also LinkPad to write some of our code. With that out of the way, let's set up what arrays are. Imagine a local startup is looking to hire a programmer that can read the temperatures of every hour of every day. And you go ahead and happily apply, you get accepted because you've been watching these C# videos and you think, I can write this kind of program. And so you sit down, I need to read a temperature every hour. So I'm going to start by having the first temperature. So I can just say int temp1, but then we get to the next hour in the day and then we need to have another temperature variable. And then we go on to the third hour of the day, the fourth hour, and we just keep going and going and going until we hit 24. But if you see this pattern, we're gonna have 24 variables all holding similar data. They're all gonna be integers. They're all named the same, and this becomes a real big pain to work with. A long list of variables, we have to make sure that we're typing in the correct names when we're referring to them, and again, this just becomes a big mess. But we have a data structure that we can work with, and those are called arrays. Arrays allow us to store a series of, let's say, just variables under one variable name. So let's go ahead and declare an integer array. We just say the data type that it's going to be, which is an int array, and we can call it temps is equal to a new int array. And when we're declaring a new array, we have to give it a fixed size. The size is never going to change. Once it's declared, that is set. This is what is called a statically sized data structure. And so we're going to go ahead and just put in a size of 24 because there are 24 hours in a day, and there we go. Instead of having 24 different variables, now we just only have to deal with one, and it's called temps. You might be thinking, okay, well, I know temps can hold multiple variables, but how do I even access them or set anything to a specific value? We just use the square brackets that we're using up in the declaration notation. So we just type the name, which is temps, and then open it up with a square bracket. And to access the first element of the array, we actually start at 0. This can take some getting used to when we start programming, but if we have any kind of list structure, or even when it comes to strings, the first character or the first element in some sequential valued variable always starts at 0. And so temps at 0, or the very first position, we can just set that equal to 1. And let's go ahead and make sure that this is working correctly. So we can do a console.writeLine and then just pass in temps at 0. And this should just print 1. In contrast, if we wanted to access the very last element in this array, at first you might think, okay, I go to slot number 24. And again, you just have to get used to that mindset that everything starts from 0 over in the programming world. So we just have to do the length -1. And so instead, we need to just replace this with a 23. And so if we go put in 23 here, we should also get a 1, which we do. If I try to access element, maybe let's go with 24, we're going to get an error. It's an index out of range exception because, again, everything starts from 0 and goes to n-1, where n is the length of whatever the structure is. There are a few ways that we can declare or initialize arrays over in C#, and specifically there's really 3 main ways to do it. So here in method 1, it's just how we declared it earlier. We start with the data type of the variable, which is an integer array here. We give it the name, so we're just going to call it R1, and then we just say new int, and then remember to pass in some sort of size that it's going to be. So we can do 10, close off that square bracket, and put a semicolon. You'll be thinking, okay, well, this isn't initialized with any variables. What if I want to start an array with some sort of elements inside of it? So here we have a character array called R2, and we can just do a new char array, and then after this we can open up with a curly brace and pass in some characters. So maybe A, and then E, I, and then O, U, so on and so forth. I'm not going to do the whole entire thing, and so make sure to close off with the curly brace, and this works just as good too. But you have to remember, since arrays are statically sized, this character array that is made will only ever have a size of 3, or the indices are ranging from 0 all the way up to 2, including 2, but not 3. Lastly, there is another way that we can go about this, and that's basically just eliminating this part right here in method 2. So here I have a string array called R3, and we can just immediately initialize it with Colton, and then like maybe my cat's name, so Mochi, and then close it off. And that is a perfectly valid way of doing it too. And as of C# 12, you can just do these square brackets, and that works too. One last thing to note is, what if I am given some sort of array through like a parameter and a method, and I want to get the length of that array? All you have to do is go down, and let's just do a print method here. So a write line method. So we're gonna do console.writeLine, and all you have to do is just give the variable name and then call its length method, or really this is just a property of the array. And so we do r3.length, and then let's go ahead and run it to make sure everything works, and we should get 2, and that's exactly what we get. But I can't stress this enough, this right here is index 0 and this is indexed 1. We have no index 2. When you declare an array of some sort of length, that array needs to initialize all of its elements to some default value. So let's give an example. If I have an integer array called r, and it's equal to a new int array of size 10, and we go ahead and try to print out the very first element within it. So we just say r at 0, we're gonna get just a 0. So when we have an integer array, every element in that array is 0, no matter what element you're looking at. Same is gonna go for like a Boolean. So if we put in bool, it's not going to be 0, but we're going to get the default value of false. And just to hammer this home one more time, if we do a character array, we're going to get like all the zeros in the ASCII table. If you remember me talking about that in a previous video, we just get a double 0. So that's great, but what if we have like our own structs or classes? So here I have a value type, which is a struct, and it's called cat struct, and every cat struct is going to have a name and age. And here's just the constructor for it. Given a name, we assign the name, and then the default value of any new cat struct is just 10. Let's change this to a cat struct array then. So cat struct, and to prevent any misspellings here, we're just going to copy and paste it right here. Now what do you think is going to happen? We have some value type, and if we go ahead and print out the very first element, we're going to get a returned cat struct. But every element within that cat struct, or really the attribute in that cat struct, is going to be set to its own default values. So name, when it gets kind of like default initialized, it's going to be given null. When it comes to age, it's getting assigned 0. So this means that whenever we're creating some sort of array of a value type, and for this instance a struct, we're not calling this constructor that the struct has, it's just giving it all default values. Things can kind of change up when we're making an array of a class. So down here in the cat class, it's an exact copy of what's going on in this cat struct, but instead it's a reference type due to its class nature. So let's go ahead and change this to class, and change this over here to class also. So if we go to access the very first element in this cat class array, which we have to run it without highlighting anything, we're going to get null. So every element in a cat class array is null. And just to reiterate on this, if I try to access the very first element in this and get its age, we're going to run into a null reference error or null reference exception, because again, we can't access the age field of some sort of null reference. So just to recap, reference types are always assigned null by default in an array, and value types are assigned to whatever default element that they get, which might be 0, false, zeros, stuff like that. What if there was some scenario where you were passed in an array and some sort of function, and you didn't know how long that array was, but you wanted to grab the last element? The only way that you can really grab the last element, and let's just go ahead and print this out, we would have to do primes at some sort of index, but within this, where we're passing in that index, we'd also have to do primes dot length -1. This is going to go ahead and grab element 13, because we're getting the length of this array, which is 6, and since its index starts at 0, so 0, 1, 2, 3, 4, 5, we need to grab the 5th element. So we get the length, which is 6, subtract 1, we get 5, and let's go ahead and run this, just make sure we're getting 13, which we do. But to grab the last element of this array can be kind of long when we're doing it in this kind of method. So instead, if we wanted to grab the last element, we can replace this section right here with a caret and then a 1. So this is the exact same thing. It's saying grab the length of this array and then subtract 1 from it, and that's going to get you the last element in the array. Let's print one more time, time to make sure this is working. And there we go, we get 13. We can change this to, and we'll get 11 right here. And we can keep on like decrementing it over and over and over. And that's how indices work. If we wanted to go ahead and make this its own type, which it already is, we can just say index, and let's just say index as the name. We can pass it in a _1. And so if I wanted to go ahead and grab that last element of the array again, we just pass an index here, run it, and we get 13. You do need to be careful though that when you are subtracting from the back and moving I guess technically all the way to the front, we can't just pass in some arbitrarily long number because we can go out of bounds. So if I do a 100 here, we're going to obviously go way past the front of where this array starts, and we get an index out of range exception. In C#, we can also get arrays out of another array, so a sub-array. Again, we're going to be working with this primes variable here, holding 2, 3, 5, 7, 11, and 13. Now, let's say that I just wanted to get the first few prime numbers out of this. So we can use this double dot notation right here, in which the first number that we pass in is inclusive. So we're going to get that number all the way through and up to, but not including the second number that we pass in. So that's why I'm using kind of more of a math notation here with this parenthesis. And so if we go down here and let's just create another int array, and we'll call it sub primes, and we can equate that to primes. And again, we don't actually use this single parenthesis. We're just going to pass in, or we're going to use 2 square brackets here. So I can do a 0 and then dot dot 2. And if we're going to go ahead and print this out just to prove what's going on here, we can do print subprimes. And so we're going to get index 0, index 1, but then since we hit index 2 right here, we don't include it. So therefore our subprimes is only going to have 2 and 3. Let's make sure that this is actually working. And there we go, is saying we have an array of int 32s that hold just 2 and 3. Let's say you just wanted to grab everything from index 3 and onward. We can change this 0 here to a 3 and then just do a dot dot, and we're going to get everything starting at 3 all the way to the end. So 0, 1, 2, 3. So we start at 7. So we're going to get 7, 11, 13, and that's exactly what is printed out here. And then what if you wanted to get all the first X elements, excluding the number that you pass in? You don't need to give a first number, but you can just do a dot dot and maybe like a 2. So this is actually just going to be an array of 0 and 1. So we're going to get 2, 3 here. And there we go. That is our sub array. We can combine this with indices. So if I wanted to get all of the elements in this primes array, except for the very last one, we can take out this 2 right here and do a _1. And so our new array will just have 2 all the way through 11. Let's run that. There we go. We get 11, but 13 is excluded. And let's just do this one more time to make sure that 11 gets excluded here when we get 2, 3, 5, and 7. And just like how indices can get, they have their own type, same thing goes for ranges. So if I do a range, and let's just copy what's going on here and pass it in up to this point, end it with a semicolon and pass in range down in this area, we're going to get another subarray 2 all the way up to 7. The last little concept that I want to cover are double array. We can also have triple arrays, quadruple arrays, but at the end of the day, a double array is just an array of arrays. So if you think of your screen, that is an array of arrays. We're in a 2-dimensional space, and you can go ahead and add in like arrays. So we can have one row, but then under that row, we have another row. And so that can be broken up into, rows and columns. So let's go ahead and put that into like C#. So if I do an int, and all I have to do is just open up a square brace and then do a comma and then another square brace that's saying, okay, we're going to have a 2D array here, and let's just call it R and set that equal to a new int array. And we just do the same thing here. We can pass in how many rows we want. So let's say we want 2 rows and we're going to have 3 columns, and that's all you got to do. So let's go ahead and print out this array. And again, as we talked about earlier, it's all going to just be defaulted to zeros. So let's run it. And there we go. We get our 2 rows right here and 3 columns. And again, if you ever want to get this top left or the very first element that happens in here, all we have to do is pass in a 0 for the 0th row, or the first row technically, and then for the 0th column, and this would print us just a plain old 0. Again, double arrays, triple arrays, these are all very powerful things, so you can dabble in them. I know that they can be confusing at first, but as long as you get some practice in, you'll kind of understand, get the hang of what's going on with a double array. Alright, that's going to do it for the end of this video. Today we covered several different parts about arrays, how to declare them, initialize them, the default values, what happens when we have a reference versus a value type array, how we can get different slices of the array using ranges, and how we can subtract from the back of the array using indices. And then we finished off with talking about rectangular arrays, also known as like 2D arrays, and how you can expand upon that, making them into like 3D arrays, 4D arrays, which I don't know why you would ever want to do that, but if you know what you're doing, then go ahead and go for it. But again, if you learned anything, then please consider subscribing and liking the video, and I'll see you in the next one.